Okay, the conversion I'm about to talk to you guys about right now, this is where we use Avogadro's number. And Avogadro's number is that there are 6.02 times 10 to the 23rd particles per 1 mole. This could be talking about atoms, molecules, formula units, you name it. Okay, it's how many there are in a mole. This type of conversion, mathematically speaking, it's not that hard because you can always just use the same number in the fraction. As long as you know where to put it in the fraction, you should be fine. The thing that people struggle with is that they mess it up on the calculator. A lot of people aren't used to using these weird exponents in the calculator, and so they end up having beautiful math, but they totally ruin it for themselves when they put it in the calculator. So please listen to what I tell you. Unfortunately, I don't have a way to put a graphing calculator on this video, so you're just going to have to trust and listen and follow along while you use your calculator. Okay? And if you need further help with that, email me, come talk to me, go talk to your teacher. We can show you how to do that. If you're really struggling with the calculator stuff, I'm sure I can make a quick video of how to use your calculator. I just don't have my calculator on me at home right now, so sorry. Hopefully you can follow along. So if I'm going for moles to particles, I'm going to use 6.02 times 10 to the 23rd. If I'm going for particles to moles, I'm also going to use that same number. So this equation is going to be given moles over 1 times 1 mole of given on the bottom, and good old Avogadro's number on the top, 6.02 times 10 to the 23rd particles. And over here, if I'm going from particles to moles, I'm going to start with given particles over 1 times 6.02 times 10 to the 23rd particles on the bottom, and 1 mole of given on the top. See how these fractions are flipped? The reason why is because we're getting rid of different units at different times. All right, so let's say that the first one, let's say that I had 1.32 moles of water. And I was trying to figure out how many molecules of water that was. I would go ahead and I'd follow this conversion that I'm writing right here. So all I'm going to do is I'm just going to multiply across the top by 6.02 times 10 to the 23rd molecules. So in my calculator, it's very important, guys, anytime you're writing these conversions, go ahead and put parentheses around Avogadro's number. In this case, it's not that important because multiplication, your PEMDAS doesn't really get messed up. But when we're doing division, it's essential that you listen to what I'm saying. Okay, so in your calculator, you would go ahead and you would type the following. So just type what I'm writing right here. You're going to say 1.32, the times button, parentheses, 6.02 times, and then if your calculator has that little caret button that looks like this, you're going to say 10 caret 23. Otherwise, if yours says times 10 to the blank, you're just going to say the times 10 button and then 23. Then you're going to close your parentheses and click equals. And when you do that, Google's telling me right now, because I don't have my calculator, that it's 7.95 times 10 to the 23rd molecules of water. If I'm wrong, please let me know. That means it's Google's fault, but I just typed this in right now, and it looks so. I skipped that bottom part because 1 times 1 is really 1, so I just skipped a step. I'm sorry if that confused you, but that should be our answer here. Let's say if we had started with 8.56 times 10 to the 24th atoms of carbon. And we were trying to figure out how many moles that was of carbon. What we would do is we'd put 6.02 times 10 to the 23rd atoms of carbon on the bottom and 1 mole of carbon on the top. As soon as I see Avogadro's number, I need to put parentheses around it. This is where you need to listen to me. I'm sorry for being feisty when I say this, but I'm trying to emphasize something for you, because I will be so sad for you if you accidentally mess this up on your test because you did the math right, you just didn't do the calculator right. And that truly, truly makes me so sad. So, whenever you're dealing with Avogadro's number and you're dividing by Avogadro's number, it is essential that you put in parentheses. The reason why is because your calculator thinks that it knows PEMDAS and wants to do PEMDAS the way... It's like a rule follower. It wants to do everything exactly perfectly. It doesn't know your intentions. So you have to give it the exact right... you have to give it the exact right directions, okay? Because it's really just like... It just follows rules. That's all it does. Okay. Sorry, I was typing stuff in and then I went on a tangent. So... I would multiply across the top. That would end up getting me 8.56 times 10 to the 24th. The reason why is because we know that anything times 1 is itself. I'm going to do the same thing for the bottom. And it ends up being 6.02 times 10 to the 23rd as the bottom. So people, in your calculator, you are going to type as I write this. Well, type as I say this. You're going to say open parentheses. 8.56 times 10, this caret button, 24. You're going to click the arrow to get down, the right arrow, this arrow, and then you're going to close your parentheses. Then you're going to click the division sign, and this is the most important thing, people. Open your parentheses. If you don't, it's going to mess up and it's going to be sad, I promise you. You're going to say open parentheses 6.02 times 10 caret 23. Close your parentheses, click enter, and if Google is telling me right after I type this in, it should be about 14.2 moles of carbon. Okay? Hopefully Google told me right. If not, comment please or email me or something. I will fix this video. But as far as me typing in Google, I believe you should have gotten that answer.